Every masterpiece of engineering begins with a single step onto an empty plot. At Construction AI, we believe precision starts the moment we arrive. Surveying equipment and structural blueprints are the first tools of the trade. Every measurement here will dictate the building's future stability. The engineers carefully study the architectural and structural drawings, cross-referencing every dimension before a single peg is driven. Using white lime powder, the exact dimensions of the building footprint are laid out, transforming paper plans into a physical grid. Nylon strings and wooden pegs define the column grid. This layout ensures that every vertical member will sit perfectly over its foundation point. The site engineer checks every measurement with a critical eye. Accuracy in the grid layout is the only way to avoid structural issues later. With the layout confirmed, heavy excavation begins. The mechanical excavator is brought in to handle the bulk of the earth moving. As the excavator works, trenches and footing pits appear across the marked grid, reaching down to the load-bearing soil. While machines do the heavy lifting, skilled workers use shovels and pickaxes to refine the edges and clear the base of each pit. The site becomes a hive of activity, with excavated soil being continuously transported to keep the work area clear and organized. Supervisors inspect the depth and width of each pit, ensuring they perfectly match the requirements of the structural design. Once the desired depth is reached, the base of the foundation must be compacted. This increases the soil's stability and load-bearing capacity. For larger areas, mechanical compactors are used to ensure every square inch of the foundation base is dense and firm. Protection starts before the first drop of concrete. An anti-termite chemical treatment is applied to shield the future building from infestation. Preparation for the plain cement concrete, or PCC, begins. This acts as a critical leveling layer for all structural foundations. The fresh concrete is transported and poured carefully into each footing location, filling the base to the required thickness. Masons use long wooden screeds to level the surface of the wet PCC, moving back and forth to create a flat bed. While the PCC hardens, the steel reinforcement work begins. Long rebar rods are cut to the exact length specified in the drawings. Bending machines are used to shape the steel, creating the hooks and stirrups that will provide the structure's tensile strength. Skilled steelworkers assemble the reinforcement cages for the isolated footings, tying every intersection securely with binding wire. These cages are the skeleton of the foundation. They are carefully placed, ensuring they align perfectly with the column grid. Proper spacing is maintained using cover blocks, ensuring that concrete will fully encase the steel and protect it from corrosion. Formwork carpenters now install the shuttering. These molds will hold the wet concrete and define the final shape of the footings. The formwork is supported with heavy-duty props and braces, built to withstand the immense pressure of the wet concrete. Before a single drop of concrete is cast, an engineer performs a final inspection of the reinforcement and formwork alignment. With the inspection complete, the casting begins. Fresh concrete is poured into the molds, marking a major milestone in the project. Mechanical vibrators are essential. They remove trapped air bubbles and ensure the concrete is dense and free of voids around the rebar. The top surface of each footing is leveled and allowed to set, forming the solid root of the building's structural frame. Curing is the next critical phase. Regular watering ensures the concrete develops its full structural strength over time. From the hardened footings, vertical starter bars extend upward. These are the connection points for the building's vertical skeleton. Column reinforcement cages are assembled, using stirrups to provide the lateral strength needed for the building's vertical loads. Tall formwork panels define the shape of each column. These must be perfectly vertical to ensure the building stays upright. Precision tools like plumb lines are used to check every column. Even a slight tilt could compromise the entire structural grid. Concrete is then poured from the top. Workers vibrate the mold from the outside to ensure the dense concrete reaches every corner. Once the columns reach plinth level, horizontal beams are constructed. These beams tie the entire foundation system together. The plinth beams are cast, forming a solid structural ring around the building's base that will support the ground floor walls. After curing, the plinth is complete. This horizontal structural band is now ready to hold the weight of the levels above. The foundation is set. In our next chapter, we'll watch as the building rises high above the ground, completing the RCC skeleton.